Question number 34. The graph shows the variation with time t of the current I in the primary coil of an primary coil. So many terms. Primary coil. This means what? This is your IP over here. IP of an ideal transformer, which means what? The efficiency is 100%. 100%. Okay. Number of turns in the primary is 100. NP is 100. Number of turns secondary is 200. NS is 100. Then graph shows the variation time of the current in the secondary coil. Which one? So you need to show me the plot of which one is correct. IS versus T, which one is it? So we know the relationship, quite simple. The relationship is IP by IS is equal to NS divided by NP, right? So what is NS? NS is 200 divided by 100, which should be equal to 2. And then you need, what is it you need? IS. IS is equal to IP by 2, okay? So which means what? Now your IP should be, IP is, if this is this much long over here, I want IS to be much lesser, half of it, right? So therefore, definitely this and this will not qualify, because you see the peak length is much higher here, the peak length is much lower here, right? This should only be of this much height. So therefore, so definitely these two will not qualify. Now once again, if you look at this here, there are two curves here, okay, which are very similar to what we have cited. One starts with the same origin as shown in the input, while the second one starts somewhere over here. So which one is the right one? So to understand this, you need to know that a transformer, we are talking about a transformer, right? A transformer has coils like this, So when a current passes through a coil, then this coil sometimes is also called as an inductor. Inductor will experience a phase change, and we say the current will lag behind. What do you mean by lagging? That means it will not go along with it. So it means when this attains a maximum, say let us say I plot, this is your input, for example, this is your input. If the input current is maximum, then the output current would have been 0 here. If the input current reaches 0, then the output current is maximum, right? When do we see? When there is a phase lag of 90 degree over here, right? How do you know this is 90 degree? See, the reason is because this is your origin point, this is your final point. In between these two, when do you get this one full thing? So this is your 360 degree, which can correspond to one time period, right? One full time period is 360. So therefore, this is 1/4 of a time period, which will now be T by 4 over here, right? Sorry, I'm not writing here. I should be writing this one here. This should be T by 4, which will correspond to 360 divided by 4, which is equal to 90 degree. Okay, so therefore, so definitely there should be a lag being observed. So this is also incorrect, because there is no lag being seen. There's a lag only seen here. Now if you ask me why is that lagging being observed, the answer for this comes from the definition of back EMF. Why do you get a back EMF? See, we need to keep on asking questions, otherwise you will not get an answer. Why do we get a back EMF? The reason is because how does an inductor look like? How does your transformer look like? Transformer looks like this, right? I wrote like this, coils over here. Now this is one coil, this other coil. Now when current passes through the second coil over here, after passing through the first coil, this coil will now produce an induced EMF. Okay, will produce a magnetic field like this over here, and this in turn will not be liked by this one, because you know it has been produced newly now. So what does it do? It tries to oppose it. Okay, thus there is a back EMF being produced, and as a result of it, current will lag behind the voltage. Okay, this is the reason behind it. If you want more questions, if you do not understand this particular part, do put in the comment section. Definitely I'll be able to help you out by making a detailed video on how does an inductor work and what do you mean by phase change. We'll definitely do it across. Thank you.